Yo, 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 lads, what's up? Oh, the gang, full gang is here. Howdy, Shriram, Idor, Rover, and our Renchi boy. Dude, I'm doing good, man. How you guys doing? I'm just tired a bit. I slept super late. Yeah, everyone is here. Low key, low keen, low keen. I like that. Okay, we'll lock in today, 100% for sure, for sure. Dude, I was just cleaning, man. Yeah, it took more than I expected. It's just because like I wasn't supposed to clean that much, but today's some people are coming, and yeah, I have to clean. Because they are family friends, and they can tell my parents, yeah, he doesn't keep things clean, blah blah blah. Okay, you going to sleep? Stay for a bit, bro. Stay with us for a bit. It'll be fun. Well, okay. Going back, right? What we have to cover today, as mentioned, I want to complete this room a bit faster than other ones. Thank you, bro. Thank you, Omi. Yeah, as I was saying, I want to cover this room a bit faster than the other ones. So, I will try to cover more. Let me know if something you want me to explain in a bit more detail. But today, at least, I will cover like introduction, TLS, and HTTPS. Only this because I have a couple of other things lined up already. But yeah, tomorrow I am free, so we will cover complete this task 5, 6, 7 tomorrow easily. 4, 5, 6, 7. Yeah, fast one because I was looking at other ones right in the what's this called in cybersecurity 101 we have like Wireshark we can do which is fun, TCP and couple of other ones which are like rooms or hacking and learning a tool which I think is way more fun. So that's why I wanted to cover this one faster. Okay, with that note, hope you guys are doing well, had a good Sunday, and yeah, let's get started. Lock in, baby, lock in. In the networking core protocols room, we learned about the protocols used to browse the web and access email, among others. These protocols work great. However, they cannot protect the confidentiality, integrity, and the authenticity of the data transfer. Yeah, I saw that. Thank you. In simple terms, when we say that confidentiality is not protected, it means that someone's watching the packets. Okay, look at that. In simple terms, when we say confidentiality is not protected, it means someone else is watching the packets, can read your password or credit card information when sent over HTTP. Similarly, we say they can access your private documents when sent via email. As for not protecting the integrity of the data, it means that an adversary, a hacker, can change the contents of the transfer data. In other words, if you authorize the payments of £100, they can easily change it to another value. So let's say £800. Authenticity means ensuring we are talking to the correct server, not a fake one. Important online transactions are risky without ensuring confidentiality, integrity, and authenticity. This is also called the CIA triage, a very basic, fundamental concept. Triad. You will see it a lot of places where it's like confidentiality, integrity, and availability. and basically every software has to provide it, I think. So, two Twitch windows are open. Oh, thank you. Thank you, boss. Thank you, thank you, thank you. Is it better now? I didn't see it. Thanks, boss. Okay, going back, right? Transfer layer security. You want me to go back again on the content? Or is it okay if I start from here? Yes. Okay, sounds good. Transfer layer security (TLS) is added to existing protocols to protect communication confidentiality, integrity, and authenticity. Consequently, HTTP, POP3, SMTP, and IMAP becomes HTTPS, POP3S, SMTPS, and IMAPs, where the appended S, the one at the end, stands for secure. We will examine these protocols and the benefit are reaped from TLS. So basically, all the protocols we learn, nothing changes in them. It's just one extra layer of TLS is added to the existing protocols to protect the confidential CIA, basically. I never knew this is actually good about this part. So, similarly, it is deemed insecure to remotely access a system using the Telnet protocol. SSH, the Secure Shell protocol, was created to provide a secure way to access remote systems. Furthermore, SSH is an extensible protocol that offers added security features for other protocols. This room is the last in a group of 4 rooms about computer networking. So we covered the concepts, essentials, core protocols, now the end, secure protocols. We recommend finishing all the previous 3 ones, learning objective. Upon finishing the room, you will learn about SSL TLS, how to secure the plain text protocols, how SSH replaced the plain text telnet, how VPN creates a secure network over an insecure one. So, please ensure you have finished those ones. Yes, sir. Okay. TLS. At one point, you would only need a packet capturing tool to read all the chats, emails, and password of the users on your network. It was not uncommon for an attacker to set their network card in promiscuous mode. I have no idea how to spell this. Bro, these are hard, man. Promiscuous. Okay, promiscuous. Is that right? Fucking Google. Google is also not working. Okay, promiscuous mode. Okay, thank you, Rover. You are my Google at this point. I love that. So it was not uncommon for an attacker to set their network card in promiscuous mode. I have no idea, but it basically says that is to capture all the packets, including those not designed to it. They are destined to it. They would.
Promiscuous.
Oh,
Promiscuous.
promiscuous. Yeah, these are the words which, as a non native, non-English language speaker will have issues. At least I will have issues. Okay, going back. Um, so a attacker can set their network card in promiscuous mode to capture all the packets, including those not destined to it. They would later, yes sir, they would later go through all the packet captures and obtain the login credentials of unsuspecting victims. There was nothing a user could do to prevent their login password from being sent in clear text. Nowadays, it has become uncommon to come across a service that sends login credentials in clear text. In 1990s, Netscape, the goat of browsers, English 101, yeah, Netscape Communications recognized the need for secure communication on the World Wide Web. They eventually developed SSL, Secure Sockets Layer, and released SSL 2.0 in 1995 as the first public version. In 1999, the Internet Engineering Task Force IETF developed TLS, Transport Layer Security. Although very similar, TLS 1.0 was an upgrade to SSL 3.0 and offered various improved security features. In 2018, TLS had a significant overhaul of its protocol and TLS 1.3 was released. The purpose is not to remember the exact dates, but to realize the amount of work and time put into developing the current versions of TLS, that is TLS 1.3. Over more than 2 decades, there had been many things to learn from and improve with every version. That's actually interesting. I had no idea. That's really respectful. Cool. Like SSL, its predecessor TLS is a cryptographic protocol operating on the OSI model's transport layer. So they both operate on transport layer, as you can see. It allows secure communication between a client and a server over an insecure network. Excuse me. It allows secure communication between a client and a server over an insecure network. By secure, we refer to confidentiality and integrity. Bringing me back to the OSI model, some stuff. Yeah, dude, that model is like something you will see every other day in that. Even like even in my DevOps task, technically, I am basically thinking in using that model sometimes to develop load balancers and stuff. It's very interesting. So, yeah, and there is something I do share. You are everywhere. Oh, that's actually cool. Thank you, Ido. This is cool. I'll send here as well. Oh, wait. This one. Okay. Going back. I'll open this. We'll go over this after completing this room. Okay. So SSL and TLS is they both are cryptographic protocols on the transport layer. By secure, we refer to confidentiality and integrity. TLS ensures that no one can read or modify the exchanged data. Please take a minute. Take a minute to think about what it would be. It would like to do online shopping, online banking, or even online messaging and email without being able to guarantee the confidentiality and integrity of the network packets. Without TLS, we would be unable to use the internet for many applications that are now part of our daily routine. Nowadays, tens of protocols have received Security. Hey Panda, have received security upgrades with the simple addition of TLS. Example include HTTP, DNS, MQTT, and SIP, which have become HTTPS dot DNS over TLS. I had no idea about this. MQTTS, okay, and SIPs, where the appended S is for secure due to the use of SSL and TLS. In the following tasks, we will visit HTTPS, SMTPS, POP3S, and IMAPS. I'm actually interested about this one. We'll check later. Technical background. We will not discuss the TLS handshake. However, if you are curious, you can check the Networking Secure Protocols room. Network Security Protocols room. Isn't it this one? It's a different one? Okay. We will give an overview of how TLS is set up and used. Okay, we can actually go over this room next to, interestingly. The first step of every server or client that needs to identify itself is to get a signed TLS certificate. Generally, the server administrator creates a certificate signing request and submit it to the certificate authority. I think hopefully you guys went through the DigiNotar episode of Darknet Diaries. That one is really great about the certificate authorities. Identify itself to get the signed TLS certificate. So going back here, the server administrator creates a certificate signing request and submits it to the certificate authority. So let's draw a bit. Okay, let me explain this thing specifically. So let's say you own google.com, right? So you will make a request to a company like a certificate authority. It's a certificate authority company. There are many. Google itself is one of them, interestingly. But let's say we go to OpenSSL, or give me a name. In Canada. DigiCert is a easy name. So we go to DigiCert, right? And we make a request. This would be a request here saying, hey, we want a TLS certificate. Can you please give it to me, right? The certificate authority verifies the CSR, right, the request, and issues a digital certificate. It will verify first, then it will issue a certificate. If you remember, right, this is one of the things I was saying in the DNS, and like when we are getting, please who oh, I see. No, we have to request, man. We have to be respectful. But no, as I was saying, right, in the DNS, we were talking about like there are so many more records. DigiCert, right? What they will say to Google, like, okay, we are going to give you a string, like a secure string, just like a password. Go to your DNS records, right, and change and for I think the record name. I forgot the record name for these ones, but if you own a domain, you will realize there's the DNS record for CAA, Certificate Authority Authorization record. So we go and we set up a CAA record in our DNS configuration, right? So DigiCert can say, okay, hey, can you change your record, this one, so that I can verify it's you. Once it's done, it takes like certain time to propagate to DigiCert. Once they do, they issue you a certificate, and you can tell the whole world, hey, I own this domain, and this is a proof. This person has checked and verified. This authority has verified this. It's same as like getting a passport. You apply for a passport to an authority. They check about you. They come to your house, right? All those things, yada 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 happens, and then they issue you your passport. It's same, very same. Once the signed certificate is received, it can be used to identify the server or the client to others, right? Who can confirm the validity of the signature. So we can tell them like, hey, this is our certificate, so this server 100% belongs to us. So if I go on this, I know this website I am connected to, the server that's hosting this, is actually TryHackMe's. For a host to confirm the validity of a signed certificate, the certificates of the signing authorities need to be installed on the host. In the non-digital digital world, this is similar to recognizing the stamps of various authorities. The screenshot below shows the trusted authorities installed in your web browser. So now, if you are setting up Burp Suite, right, you actually add extra, if I'm not wrong, you add another certificate, right, authority in your browser. But what these authorities are, your browser already has a list of authorities. It say, okay, I trust these many, like it will have DigiCert, and like it will have hundreds of more to say, okay, I only trust these ones. And when the DigiNotar case happened, right, it was such a big one, right? DigiNotar case, when happened in 2011, they were still part of your browser. No, I'm not showing. What's the point of showing, bro? Everybody got it. Nah, it's fine. But I was just saying, right? Like as I was saying here, DigiNotar was also a name, right? But because they became like they got hacked once, all the browsers just removed them. So their comeback was impossible. And that's why the company, I think, closed in. And nobody wanted them after that, like almost. Announced its closure after filing bankruptcy. So in 2011 only, they had to close, I believe. A hacker compromised DigiNotar's network and issued fraudulent certificates that would be used for malicious purpose, like eavesdropping on user accounts. So like it was, I think, $20 million, some couple million, double-digit $1 million business gone overnight almost. So it's like it's such crazy thing with tech. It's like the whole world just went against the company in a second. Generally speaking, getting a certificate signed requires paying an annual fee. However, Let's Encrypt allows you to get your certificate signed for free. Finally, we should mention that that some users opt to create a self-signed certificate. A self-signed certificate cannot prove the server's authenticity, as no third party has confirmed it. So, what is self-signed versus a CA signed certificate? A CA signed certificate, self-signed. Now, if let's say, right, like self-signed is more like, okay, you have a driving license, or you have your driving license or your identity card, right? which mentions your name. So you meet someone, you can just say, okay, this is my name, right? Here you can check, right? Whereas self-signed is like, okay, this is my name. You just tell anyone that this is your name. They have to trust you or they don't, right? They don't believe you. It's their choice. But in this case, you have a way to prove that you are that person who you are saying. This CA certificate is for, like, let's say you want to have clients, right? You want to have users on your website. You want to have the trust there. Why self-signed is a thing? Let's say when you are setting up, right, your containers, right, multiple containers you are setting up, and there is going to be communication between all those containers, or you are setting up multiple servers. Some of them, right, require, like, will be one of them will be a web one of them will be another, let's say a networking one, right? There can be different ways of having this communication, of different things they can have communication about. Some of them will require a certificate to talk. They do not mind if it is not a CA certificate. They want a certificate because some of them will be web servers, right? So then, as a DevOps person or as an engineer or tech guy, I will use self-signed certificate to get this thing, to get this communication. Is very easy. It's like I think 4 or 5 commands. You are good to go. And we can have a quick look. Steps to get a self-signed certificate. So open, generate a private key, sign a request, finally a self. So 3 or 4 commands, yeah. And you should try it. It's actually fun, and you can use that on your website, but then it will not say secure because you are not a certificate authority. What is the protocol name that TLS? Excuse me. Okay, lads, time for some quiz. What is the protocol name that the TLS upgraded and built upon? Which type of certificates should not be used to confirm the authenticity of the server? Let me know. I am waiting for you in this case. Ren, Sriram, Rover. Idor here? Idor still here? Panda, what is the protocol name of the TLS upgraded? No, you do it. You have to do it. Come on, come on, come on. You know about this protocol name that TLS upgraded and built upon. This one was developed by Netscape, 1990s. In 1993, I think it came out. Or 1995, it came out actually. Yes, sir. Thank you. What type of certificate should not be used to confirm the authenticity? Okay, I'll do this one. Self-signed certificate. Beauty. Okay. Oh, Nasdaq jumped a lot, eh? Nice. Yes, sir. Yes, sir. Okay. Now going to the next one. Okay. I'll just make this a bit smaller because I just realized Panda could not be seen by you guys. Here. Okay. So HTTPS task 3. Let's see how big that is. Okay, we can cover HTTPS. So, HTTPS task 3, HTTP. As we studied in the networking core protocols room, HTTP relies on the TCP and uses port 80 by default. We also saw how all HTTP traffic was sent in clear text for anyone to intercept and monitor. The screenshot below is from the previous room and it gives a clear idea on how an adversary, a hacker, can easily read all the traffic exchanged between the client and the server. So let's say here, as you can see, right, get the slash, so the root using HTTP 1.1, right, and other information, also the host. In the now we have HTTP 1.1 200 OK in Nginx, and this is all the web page. Art of Express. Let's take a minute to review the most common steps before a web browser can request a page over HTTP. After resolving the domain name to an IP address, the client will carry out the following two steps. So, client is the web browser. Establish a TCP three-way handshake with the target server. So let's say I talk to Facebook and synchronize, acknowledge, all those things are going on. Communicate using the HTTP protocol. For example, the issue HTTP requests such as get the root directory here, HTTP 1.1 or the homepage, whatever you want to say. So, the two steps described above are shown in the window below. The three packets for the TCP handshake marked with 1 precede the first HTTP packet with GET in it. The HTTP communication is marked with 2, and the last three displayed packets are for TCP connection termination are marked with 3. So if we see first, oh, interestingly, we have the same thing here. Bro, I have started listening to Darknet Diaries. They are so interesting. Rupankar, what's up, bro? Long time no see. Bro, they are really good, man. I love his delivery of content, the way he speaks, and like his script is so top class, so top class. I'm happy. I like that. I like that. I'll take a screenshot of this and send to Jack Resider. Okay, so we have source, right? That's us here. Not the best. We have the source here. How about this? Nope. Okay, so we have this source, whatever this is. I can't draw whatever. I have texted him, and interestingly, he has replied back to me on one of those social medias, which was very interesting. Like he replied out of blues. So I technically don't have contact. He just sent once. He replied to me once. That's pretty cool. Yeah, dude. I just send people text sometimes. I also texted this guy. I don't know if you guys know him. Gollum Fund. This guy, Brett Johnson. So this guy will reply to. He's really good at replying on this one, Twitter. So if you actually text him, like say, hey, love your stuff and things, he will actually reply. He's really good at it. Yeah. I'm one of those guys who will just send people message, and yeah, If they reply, great. If not, I'll just move to the next person. Yeah, Column Fund is a really cool person. Is really cool. The OG of Shadow Crew, man. Shadow Workers or something. It was something Shadow, right? Column Fund. Shadow Brokers, right? What was that? Shadow Crew. Shadow Crew, it was. Very interesting stuff. The OG, Dark Web OG before everything. Okay, let's go back, right? And it go text him on Twitter and say, yeah, hey, he's doing great and stuff. He likes that, man. So, going back, the first one is our TCP connection, right? This is our IP and this is our destination IP, right? This is the server we want to talk to. We send sync message here, right? We send our sync message, then the server responds back with a sync and acknowledge, and last after that is just the acknowledge from our side. So this part here, this one, is all TLS handshake. Oh, TCP handshake, three-way handshake, right? After that is the communication starts with the HTTP, as you guys can see with the protocol name here. From our side to the server, we get the HTTP request and the server responds with the data. It acknowledges and sends back the HTTP OK message. And then at the very end, right, or if there is none, it sends 404 as well here. And last are all TCP again, but these are finish, acknowledge, and acknowledge. So this is the closing of our TCP connection, three-way TCP closing, right? So now let's go over HTTP over TLS. HTTPS stands for Hypertext Transfer Protocol. Secure. It is basically HTTP over TLS. Consequently, requesting a page over HTTPS will require the following three steps after resolving the domain name, after we got the IP, right? Establish a TCP three-way handshake with the target server. Establish a TLS session. Communicate with the HTTP protocol. For example, issue HTTP request. So the only extra step here, instead of two, there is three steps, which is includes establish a TLS session before we start talking. The screenshot below shows that a TCP session is established in the first three packets marked with 1. Then several packets are exchanged to negotiate the TLS protocol marked with 2. 1 and 2 are where the TLS negotiation and establishment take place. So first screenshot below, TSS session is established in the first three packets. One and second one is about the negotiation of TLS protocol. Finally, HTTP application data is exchanged, which is marked with 3. Looking at the Wireshark screenshot, we see that it says application data because there is no way to know it is indeed HTTP or some other protocol sent over 443. So, copy here. So as you can see here, one thing interestingly, it's giving me so much data here, right? On this, okay, what is the text, what is not found, favicon icon, all those things, right? Now let's look at what this one will do for us. Okay, let me just drink some water first. Okay. Okay. So from our side, we sent to our destination, our website, request, right, for handshake, sync and acknowledge. So this right here does the job for us. This is such a bad color to use in this case. Here, more visible, at least better. So we have this, right? This one is all TCP connection happening. Now we are talking, we are setting up our TLS communication. Client says hello, 443 going on, right? Server hello, chain cipher. So chain cipher, you guys are talking, in this case, me and my server, my browser and the server, talking about which algorithm to use as well. Chain cipher specifications, all those important stuff, right? Because if there is some cryptography happening, you need to talk about what will be the algorithm to use, right? And mostly, like, there are very standard ones for this case. Couple of one or two are usually used everywhere. Now this one, third one, is all the application like exchange we are seeing. And if you see here, that's what they were talking about: application data, application data, application data. You don't see HTTP GET request on the root server. You don't see 404 not found. You don't see the GET favicon, all those. All you see is application data, because you need to break the cryptography for this. As expected, if one tries to follow the stream of packets and combine all their content, they will only get gibberish. As shown in the screenshot below, the exchange traffic is encrypted. The red is sent by the client and the blue is sent by the server. There is no way for you to know the contents without acquiring the encryption key. So this is the same communication, right? But as you can see, it's all encrypted. Getting the encryption key, adding TLS to HTTP leads to all packets being encrypted, right? We can no longer see the contents of the exchange packets unless we get access to the private key. You can read that. We can no longer, that's actually funny. We can no longer see the contents of the exchange packets unless we get access to the private key. Although it is impossible that we will have access to the keys used for encryption in a TLS session, we repeated the above screenshots after providing the decryption key to Wireshark. The TCP and TLS handshakes don't change. The main difference starts with the HTTP protocol Mark III. For instance, we see when the client issues a GET request. Sure, GET post request. Okay. So let me put it in real world example, right? So it's easier to understand. Now, Rupankar, let me ask you this. Let's say this is you, right? So this is you, right? And then you are not a noob, man. I'll do a little bit more this, a little bit more this. Okay. Now I'm ready. Okay. Ruparka, let's say this is you and this is, let's say, a shopkeeper, right? So whenever you go to a shop, right, to grab something, what do? You do a request. right? You request for something and the shopkeeper says, okay, let's say you requested a chocolate, a special kind of chocolate, right? Let's say you got a chocolate. The shopkeeper says, okay, I understand your request. Understood? Or first he says, like, let's say, okay, request, I got your request. And I understand your request, right? I understand. And yes, I do have it. Yes, I have it. It has it, so it will send you a chocolate. Now, there are so many varieties of chocolates, right? You requested for a specific one. Shopkeeper said, yes, I understand. I got your request. I understand what you're asking. I got your request. Here's the chocolate. And then once you receive the chocolate, let's say this is your brand. You say, yes, this is exactly the one I'm looking for. You tell the shopkeeper, yes, I was looking for exactly this one, right? This is first the request response with TCP, right? Why this is important to understand, because on HTTP is also built similar way, right? So you understand TCP now, first of all, with the request response from TCP handshake. Let me know if you don't, right? I will explain again. Okay, awesome. Now, HTTP is same thing, right? HTTP is the same idea in which it's again you and the shopkeeper you shopkeeper. So there is, instead, right, of asking, right, that this is exactly right, let's say he knows you very well. For example, let's say he knows you very well, you go there a lot. You now ask for, and he knows all your brands you like, or if let's say there's only one type of brand of chocolate there, right? No, so TCP is actually required before you HTTP. They both have request response, but I will show you why TCP, and where is the difference between HTTP and TCP, right? So let's say you go to this one, right? And important note, right? For every single thing you ask, whether you ask for rice, whether you ask for chocolates, whether you ask for water or a soft drink, right? Like a Coca Cola or something, it has only one brand of all, almost. Think about it. Just for example, we have like one brand of all things, right? So let's say you again ask for chocolate, right? You ask for chocolate, and he says, okay, I only have one brand, right? You let's say, even if you requested for a chocolate, in your request, let's say not even one brand, let's say in your request you mentioned, I want a good clear mention. You mention that I want 5-star, right? You mention in your request you want chocolate which is 5-star. Shopkeepers understood that and gave you your 5-star. What you did, you sent a get request. This request right here was a get request, and this was a response to your request. Now if you see, in this case there is no last third one that, okay, yes, I got it, all those stuff is happening, because you send something, shopkeeper knows it is only one brand, right? So he gives you that response, right? Same thing happens with the browser, your browser. and let's say Facebook or any other site, FB, right? You request, say, hey, my name is Ruparkan, right? After logging in, let's say you requested that I want get me the page which says my profile on it, right? Instead of chocolate, you want a page, get me the web page. Instead of 5-star, you mention, right, which exact profile page it should be, profile page. You send to Facebook. You are not only sending just this request, but you are also sending extra cookies, so much more information, right? I didn't mention because no need, I guess. So you send that, Facebook processes it, says, okay, yes, you are the person, right? It creates that web page or renders that web page, right? And gets you back the response. So this is the get and this is the response. Are you good with this? You understand this part? Get request of how HTTP works? Okay. Now last we'll talk about the post request. There are more, right? There are so many more, but I think get and post are very important to know. Now post request, for different things, let's say for get you are just getting, right? It's like verbs, right? Get, post, all these are basically verbs. Get, post, almost, put, delete. These are almost like verbs. Get is like, hey, can you get me something? Post is like, hey, can you add this, right, to the system? Can you update this? Can you delete this, right? All these are basically, every single one of them have their own verb type explanation. So post, as I mentioned, is about adding stuff, right? Going back here. I think no need to make this. I think you understood this part. So now it's you again. Insomnia, what's up, brother? Disrupted by your lesson. I'm shocked about the prices of Twitch now. Holy shit, they are very expensive now, but I want to support you and the community. I'm sorry I can't stay in the stream for long. However, I respect your work and... Oh, wow! No! Thank you so much. Holy. Insomnia, thank you, man. But no, don't... You don't have to give me gifts, man. If you want to support, right? Whenever you get time, just maybe help somebody in the stream, like in the Discord. That's all, man. And just hop in whenever. Thank you, though. Yo, everyone, one thing, though. Happy birthday. Big happy birthday from the censored hacker community to Insomnia, man. This guy. I want everyone... Oh, I'm not following. I have to... Everyone, say a very happy birthday. Belated happy birthday, I guess. But happy birthday to Insomnia, lads. I want messages. Fill the chat. Fill the chat with the messages. Ooh, what is this? Yo, unlocked emotes. Nice. Cool. A very happy birthday, Insomnia, man. It's so nice to see you, man. It's so nice to see you. So nice to see you. Thank you so much, man. Thank you so much. Give me the... Wrench is asking for birthday party. You know the guys from Delhi, man. The first thing he says is like, happy birthday, the very next thing. Now I want party. Yeah. Thank you, man. Insomnia. But yo, no sus from now. Like if you get time, right, just hang out. And I think hanging out in the Discord and like you just popping in does a big way more thing to me than like anything. Thank you so much. Though. Thank you so much. We have to meet in person though. Like Rover, you, me, Wrench, Shriram. especially Wrench. I want to talk to Wrench specially. Okay. Also, so going back, right, quickly, we have, and a big thanks again, Insomnia. Thank you. And a big happy birthday. Nah. I have been going to gym for a reason, buddy. I'm no problem, bro. Yeah, I know. I've been going to gym for a reason, Wrench. I've been going to gym for a reason. Joking, bro. Joking. Okay. Upankar, right? Going back to the post request, right? Post is mostly about adding. Gotcha. Nice. So, in post request, right? Let's say you are on Facebook again, right? You tell Facebook, or let's say let's go with the shopkeeper example first, then we can go to a real world example. So, shopkeeper, right? You went to the shopkeeper, but instead of this time as a customer, you are a salesman. You are selling, let's say again, chocolates, right? You tell the shopkeeper, hey, I want you, right? Or let's say you are the owner of the shop. That's way easier. Let's say you are the shop owner, right? And you have somebody working there. Sounds good. You have a worker, right, under you, your employee. So, as a shop owner, right, you look at all the shelves, right, all the things that are there. You say, okay, I like this brand of chocolate, and that's not there, right? But you received the shipment yesterday, right? So, what you said to the worker, like, hey, add these new chocolates we got, right? This new chocolate to the shelf, right? You made a post request. Ooh, hype chest. Ooh. Yo, we got a hype. Hey, nice. They also go cho. Okay. So going back, right? You are the owner. You said, hey, add these chocolates to the shelf. The worker said, yes, sir. And he adds it, right? On the shelf. And you get the response that yes, add it. After he adds, right? Yeah, it's Coco. That's amazing. Okay. So you see exactly what is going on. Add these new chocolates to the shelf. Yes, sir, I will add them. And once he said yes, add it. This is how a post request happens. This is where you are telling it to, hey, add this thing to this. So now on actually Facebook, this exact thing you do every time. Facebook, Twitter, whatever, right? You say, I want to add a comment. I want to make a post of something, right? I want to add a comment, right? You want to add a picture, a video, whatever, right? Whatever content you want to add to your profile, right? You send to Facebook, right? Again, there are cookies, everything. Things have, after those have happened, right? That Facebook, right, adds this to your profile. to profile, right? Or your timeline, whatever it is called. I don't use it much. Adds it to your profile and says, yes, added, right? You might have seen this. When you add this, it says, okay, a green thing saying, okay, yeah, post added to your timeline successfully, or picture uploaded successfully, whatever, right? So once you add to the profile, Facebook says, yes, this is added, and you get that green box saying, yes, uploaded or added or whatever, yada, 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 right? That's a post request, right? Same thing happening, just like the get one, but in this case, it is like instead of a different verb, it's just the changes of the verb or the type of action to do, but method, the boilerplate, right, is same. Awesome. So I'm happy you got it. That's awesome. We were here. The TCP and TLS handshakes don't change. The main difference starts with the HTTP protocol Mark 3. For instance, we can see when the client issues a GET request. So here we see, in this case, copy image. And this is after we have provided the private key to our Wireshark. Same thing, right? If we go here, first TCP connection happened right here. Then the TLS handshake, where you are talking about the cipher, right? You are talking about the algorithm to use, the encryption algorithm. Now here, same thing is happening. There is data going on, stuff like that. But we have the private key now. So we are able to see what exactly is going on. Nothing is encrypted. So we see in one of this one here, this specific one, we see a GET request was made. GET login. And you can see there is transfer layer security over TCP mentioned. And that's basically how things work in communication. Over TCP, there's TLS, and then TLS you put anything. By the way, CS, thanks for the reminder. I got little lazy today. Now you have fired me up. Make you regret your words. You will never be able to beat my ass, bro. Don't worry. If you want to see the data exchange, now is your chance. It is still regular HTTP traffic hidden from praying eyes. So you have all this information, right? The key takeaway is that the TLS offered security for HTTP without requiring any changes in the lower or higher layer protocols. In other words, TCP and IP were not modified while HTTPS was sent over TLS and the way it would be sent over TCP. I am 6 or maybe 6'1". Maybe I'm between 6'1", right? I'm there. I'm definitely above 6. I know that. And you can see, right? There is cookies. There's so much more data to help. I know your one hand is bigger than the other, but I will beat you for. Bro, if I use that hand, I think you will be dead, man. How many packets the TLS negotiation and establishment take place in the Wireshark HTTP screenshot, right? So let's go over here in the TLS one. That's our second block, right? So we see this is our second one. So one, maybe little here. So we make sure these are the right IPs. So 1, 2, 3, 4, 5. What's the 8 means? Wait. 8, you mean like 5 plus 3? I thought 5. No. It's 5 plus 3? Okay. Interesting. What is the number of packets that contain the get login when accessing the website over HTTPS? What is the number of packets that contain get login? Oh, like number here, the serial number. So that would be 10 right here. They should mention what is the serial number. Awesome. So we completed a good amount of stuff. That's good. That's really good. So we are able to probably complete this tomorrow as well, right? It's like STP, SMTPS, POP3S, already done Ranchi. POP3S, IMAPS. We will complete this tomorrow. SSH, SFTP, and FTPS, and VPN. VPN is a good way. I have a really good way of explaining things, so maybe I can do that. I might go a bit illegal in this case, though. If you want to understand VPN and like what I'm talking about, maybe look at a video by Johnny Harris on Pablo Escobar. That's all I can say. He did a really good job talking about tunnels in that. Renchi boy. Pablo Escobar. Yeah, this one. Prison break that embarrassed an entire country. This video. Really good one.
Every business owner.
Because this one you guys will see fun info in, right? And why I will be using this to talk about VPN. It just clears the mind of anyone. Brave? I actually use Brave, but that's for like other stuff I use Brave. I have Brave, but I just use it for some other personal stuff. TwinGate. What is TwinGate? It's time to ditch your VPN. Oh, okay. Zero trust orchestration layer, so you can create best in class security. Oh, okay. That's cool. I have never heard of it, but it looks cool, bro. Just a ad walker, bro. uBlock origin, like really it looks way more up higher. Network chunk always makes ads for them. Okay. I have no idea actually about this one. I can look more into it. I've never heard of it. So it's, let's say if we are talking about VPN, one thing I know, if you're selecting a VPN, right? One thing I know is I will never go for an American company when it comes to VPN, because a lot of American companies keep all your records. It is one of the biggest sponsor. Oh wow. Yeah, that's cool. But like VPNs when you are getting, right, never get from American companies, because FBI, these people have like backdoors in this in those companies, and they keep a record of all the logs. So if anybody wants, let's say, the logs of Wrench, Insomnia, Rupankar, even me, using those VPNs, we are technically not secure. Use like, I think there is a Swedish company or somebody somewhere in Europe which is like really good, and they just destroy. They never keep any records. So when I think FBI for one of the cases wanted the record of a person, they said we don't have any. They went through like all the process and everything. Still, they were like, yeah, we don't have any. How will give you? So this is actually cool. I can look into it. What it is? Identity-based access for user service and AI agents that deploy in minute scale to every resource finally lets you retire your VPN. Nice. And this is like big gamer, big play. Pay you windsurf. Oh, okay. They will never find me. Malware everywhere. Bro, you live in. I know where you live. Like, where you hiding from, man? Okay. Thank you, man. I will have a look and I can probably give you a better answer after that. That's amazing. Okay. But alrighty, guys. I think it's 9, so I have to go back to work. Started at 9. So, yeah. Thank you so much. A big thanks to Insomnia for all the subs, man. Thank you so much. Thank you so much for that. Really appreciate it. Um, yeah, Network Chunk's whole server home lab works with TwinGate and his big show. Oh, wow. A flipping switch. Yeah, dude, that's actually crazy. I have to look into it more then now. That's awesome. Okay, thank you so much, lads. It has been a great day. It has been a great day. Great start to Monday. Great start to this week. Thank you so much. Hope you guys have a great day, great night, and I will see you guys in the evening for some lead code or die. And we are going to work towards our first medium problem in top 150 interview list. Till then, thank you so much. This has been your favorite sniffer of packets, sensor hacker, signing off with a big bye. Thank you so much, lads. Thank you, Insomnia. Thank you, Wrench. Thank you, Rupankar, Rover, Idor, Sriram. Thank you, lads. Panda, thank you so much. Bye. Bye bye.